Morning, folks. How's everybody doing today? Alrighty. Happy Tuesday. Let's turn that down a little, sorry. Alright. Whew. Hey, Super Blakes. That's so cool. Thanks for tossing your Prime sub over here. That'll go towards the Student Scholarship Fund at the University of Michigan Dearborn, where I'm both a student and a lecturer. That's kind of cool. Hang on, I didn't want Slack open. I want to close that one. What did I want? I wanted the other one open. There we go. I found it. Let me get logged in here to D2L. See if that logs us in. Alright, and we are this one here. Hey, Gator and DL Day. Alright. Cool. Got a couple more quizzes and labs in here. Not too bad. Don't forget that syllabus quiz due tonight by 11:59 p.m., please. Okay. Oh, I don't want that one. I want my other one open. One of these days I'll remember how to do this stuff. Alright, so the lab due on Thursday before class. So that's our getting started with Git here. And let's see, let's pull up our syllabus. Make sure we're on track for our schedule here. I started more coffee. It is not done yet. I'm sad. Oh, actually, I've got a little bit left. I thought I finished that off. All right, so we're going to talk about arrays and array lists. We'll get to file I/O on Thursday. Programmer socks. Do you have programmer socks, Joey? I have socks with like the matrix binary stuff on it. I don't know if I'd call them programmer socks. I do like fun socks. Fun socks are a lot of fun. Crazy socks, whatever. Those are fun usually. All right. So that's the plan for today. So we'll do arrays and array lists, and then we'll get to file I/O. Given we're tackling some different topics here, I think we're going to do a lab for arrays and array lists, and then we'll do a separate lab for file I/O. And then that first project, project 0, because you remember with arrays and things, we start at 0 for our index. So we might as well start our projects with index 0. We'll cover both of those topics as well. We should have some fun. Then we'll spend lots of time on classes, inheritance, interfaces, object-oriented programming, the core fundamentals of object-oriented programming, and we'll pick up units as well, and we'll talk about project 1. Then we'll talk about exceptions, and then it's already time for the midterm, believe it or not. This one's a little bit early, but I wanted to have it before break so that way everything is done and out of the way for break. We'll come back to Java FX. Hopefully everyone did that in 1500. I think almost everyone did. So it'll be a little bit of review, and then we'll pull up some more interesting stuff the supplemental week. I just got some additional things I want to show you, fun things we can do. We'll do a Java FX project. We'll talk about databases, line expressions, multi-threading, annotations, and design patterns. And then we are on to the final project and done with the semester, believe it or not. So we're looking at April already. So this semester will fly by, I think. All right, so got NetBeans going. Let's let that load. Again, I do post the links for previous classes here, and they should just start building up here in the lecture archive. So as we go, I'll just keep on posting them here. Eventually, you'll have to click more, because I think it only loads, I want to say 20 links at a time, and you have to say, I want to load more links. So that'll be there. You can watch them out on YouTube if you'd like. And then the course repository, where I keep all the code over in class, you can link to here in course information. And if you like PowerPoint slides, of course, the textbook slides are here for you as well. Not a big fan of PowerPoint, because usually you just end up reading to people. And that's not a lot of fun. Or, you know, a slide goes up on the screen and then you folks start reading it because you're all wonderful readers, and then you're not really listening. And not that I have the most interesting stuff in the world to say, but we don't make very good multitaskers. So ideally, we'll try and focus on one thing at a time. I'll give you some examples. The book will give you some examples. You'll practice some examples with labs, and then you'll get a project. Right? So that's like 4 chances to try all this stuff. Should be fun. And again, the goal, lab-based class. Ideally, you'd get these labs done and out of the way in class, like in that practice time. So my goal is to talk for about an hour or so, maybe a little more, maybe a little bit less, kind of depends on the day, and then turn it over to you folks to work on that lab for practice. The projects are ones that you'll be doing on your own time, and I'll post some quizzes as well. Let's see, because we've got arrays and array lists, so we don't actually touch much out of the chapter 12 with array lists, so I won't do a quiz on that. We'll do a quiz on the arrays chapter and a quiz on the file IO chapter. Hey, deal day. Cool. Glad that works with your style. So I know not everyone likes my style, and I do feel a little bit bad about that it doesn't work well for everybody. But generally, I see pretty good feedback that this sort of style works well for people. But you know, I'm always open to changing things up to help everyone out. So, all right, again, we're going to do a Java with Ant Java application here. This is probably the easiest one. Again, Maven and Gradle should be fine, but every so often we run into some issues with them. So Java with Ant is probably the easiest. All right, I'm going to drop it in the course repository folder. Remember, a Git repository is nothing more than a folder that the Git source control tool watches. So I'm going to go to my Git folder, and I'm going to find the right one. So you folks will have one for every lab, every project, right? So make sure you pick the right folder so that Git can see your stuff. So CIS 2051 Winter 2022 is the one I'm doing for all of our course examples here. And we'll call this one Arrays and Array Lists. Okay. And it should get us started here. And I can check and go to my Git client here. Maybe. Come on, computer. I know it feels like a Monday, computer, but really it's Tuesday. You don't need to be so slow. I didn't get a fresh reboot. I've been trying to do a fresh restart every morning, but I did not do that this morning. Okay, that's my bad. And I'm sad you can't right-click and get the task manager anymore to see what's using all the resources. You have to use your handy-dandy shortcuts. The Control-Shift-Escape will pop open the task manager for you here with Windows 11. It'll still do it, but you don't have that right-click option anymore. I'm going to change my repository here, make sure I'm in the right one. So this is 2151, and we are in winter 2022. Let's see, what's using up all my CPU? Let's see. Yeah, we'll see. I've got some NetBeans project files already that are showing up, which is good. All right. Oh yeah, the desktop Windows Manager thing always likes to bother me. Windows audio device graph. This is weird stuff here. Why audio device graph? Isolation. Oh, neat. My Windows camera frame server. All just fighting for resources here. That's kind of a bummer. Edge. Okay, let me start closing some tabs in Edge because I probably don't need all these open anymore. We'll come back to some of those later. That'll free up a little bit. Edge is a hog, which is unfortunate. But any Chromium browser is going to be a big hog. Let's see, is it cooperating a little bit better now? Yeah, I don't know why this audio thing is so weird. You can use any email you want for GitHub. Doesn't matter. It defaults to one that's like some weird private one, like a do not reply. Yeah, it's eating up all my CPU. Discord is a little bit. I guess I can quit Discord. I don't need that yet. Just see if I can free up a little bit of space here. Maybe. I think NetBeans is about, nope. Background skin. And I like all the comments. I should just update the template. So don't need to get any repositories yet. Tresaurus. You know, when you get to the lab, you can do that one. Yeah, that's fine. Mike's functional artistry. Okay. Yeah. I should. Part of me is tempted to get a decent desktop for here for my home office, but then I still have to take the laptop and I go places, and I still stream from classrooms and stuff. So, you know, part of me is like, just get a better laptop. I don't know. We'll see. Then look at that. Now I got some space. NetBeans finished its thing. I blame NetBeans. I mean, OBS that's only like 20%. That should be fine. This audio device, that I've not seen that one taking up lots of CPU before. That's kind of a bummer. I don't even think I'm doing a weird anything. It's just the regular camera here, or the regular mic, but okay, we made it. I get the desktop, it gives you the opportunity to dump the laptop, get it running 100%. All right, so we'll start with some basic arrays. So everyone should have talked about arrays in 1500. Now remember, arrays are basic in that they are fixed in size, right? Which is one of the downsides with an array here. So I'm going to say, hey, I want, how about a string array? And I'm going to use these square braces to indicate array. So string array, let's say this is names, and then we have to use our syntax equals new string array, and then what size? How many names do I want to put in here? How about let's go with 8 names. Okay. So square braces to show that it's an array equals new, using the new syntax, string array of what size here. So now each individual index here, starting at 0, I can assign or get values out. Right? When it starts, it's going to be empty. I'm not going to have anything in here. So I'm going to go put some values in. So let's do, how about Eric, and names of 1, do Jasmine, names of 2, Joy, oh goodness, I can't type this morning, names of 3, and on and on and on and on. Right, so at each individual index, then, we can give it some values. Now this is kind of a small pain, right? If we know what all of our values are going to be, to have to go through one at a time. We could do that, but it's a little easier to use the initializer syntax. Right, so you can say, hey, string, oh, we already declared names, so you can just say names equals, and I can just give it in curly braces, I can give it a bunch of values. Jasmine, Joy, Jeb, Genevieve. One of these days I'll be able to type. My fingers just don't want to move this morning. I don't know what's going on. Like, I don't know, they're just tense. Journey, keep on going. Jubilee, Jackson. Is that 8? I think that's 8. Oh. String array. How about more names? Happier with that? What is it not like? I think it's only written to. Oh, no. New string array. Oh my goodness. Friends. Why is it hating me right now? Alright, so this is why I guess I should use the PowerPoint slides. Dot, 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 dot. Is it not? Never read from. It's fine. Gave it a closing curly brace. Missing a comma, missing a comma. Missing a comma. That was my problem here. Okay, I had the right syntax. It was just a comma. Alright, so if you know what's inside of your array, you can just give it a big list here with this initializer syntax. So this one is the initializer syntax for arrays. Notice you don't have to tell it what size, because it can count how many things you're giving it here, versus doing it one at a time. Right, one index at a time. Now, nothing wrong with either way here. I think this is probably more common and preferred. I know that errant character, and like, sometimes the suggestions are like, hey, it looks like you're missing a comma. Nope, this one just had no idea what I was doing. It's terrible errors. All right. So to get values, right, you do it by index. Again, we start at 0. So we always have the number of indexes as our size. So I'll have 8 indexes here, but the index values are 0 through 7. So most commonly when we loop through, we'll say for int index is 0, index is 0, index is less than. Now, when you're looping through an array, you always want to use length. You can say the array.length is a property you can always get at here, because this will always be the correct length of that array. I can take my index plus plus. Now, I know some people are fond of the letter I. I hate the letter I. I will always write out index because it's not hard, and a lot of times I get confused looking at I's to see what if it's an L or other characters, or I don't know. I guess a single I is not the worst thing in the world, but I definitely prefer index. We can say, hey, I want more names of index, and I can print my values out. So this is the traditional loop through an array. Now you also have the enhanced for loop. Enhanced for loop. So this loops through items in a collection. Okay, so we can say I want for string name, colon, we'll do more names, because that has more values. So this says for every string in the more names collection, call it name. So inside the loop then, I can use name. Now, the note about this one is read only, essentially, because what's happening here, when you get name out of the more names list, you can change it, do anything you want to, but it's not going to affect the more names array. Versus when you have the index, you're able to change the item at that index and modify it. Right, so if I were to take name and say, let's do name dot upper, right, to uppercase, right, we can say, hey, how about name equals name to uppercase. Remember, strings are immutable. You can't change a string. So if I want to change the string, I need to reassign the value here. So let's make it uppercase, and then we'll print it again. right? So if I change name here, it's not going to change inside the array, right? Because we're changing our copy of that we're using outside the array. This gives me a copy of this value, right? That's why we're saying it is read only here. So then if we're going to go and print it again, we'd get the exact same results. Okay, let me, let's do that one after, I guess. Now let's give that a quick run. Make sure that this one does what we expect it to do. So I should get out the names of my family. I'm the only not J. You can blame my wife for not marrying someone with a J name. All of our kids have J names, which is kind of cool because her grandfather had a J name, and all of his kids had J names, and so on and so on and so on. So it's kind of cool. Not everyone in the family followed the tradition because it starts to get hard to find more J names that one of your cousins haven't used, but a lot of them did, which is fun. So we get regular and uppercase all the way through, but then we get the regulars again back when we loop through it again, right? Because we haven't changed what's inside the array. So that's our basic array. Now what's really fun about array lists is that you don't need to give them a fixed size. So array lists are fantastic. So I can have an array list. Now array lists get a funky notation. So you say array list and then you use these greater than, less than brackets. We say this is the type of string. We'll call this, I don't know, my array list of names equals a new array list. And then this is actually a constructor, so we need a set of parentheses here, which is really funny. And it's going to tell you it doesn't know what an array list is. And that's okay. We're going to tell NetBeans, hey, give me your little light bulb hint here. And it should say, hey, do you want to add an import for java.util.arraylist? We say, yes, please. Or you don't, you can go type it yourself. Go nuts. Again, I'm going to try not type things that I don't have to. So the array list, right, you tell it what type it is here. And then here you just leave it empty, again, but it's the greater than, less than signs, and then a set of parentheses, because that's calling the constructor. With the array list of names, then we have options. We can take my array list of names, and I can say dot, and I get all sorts of cool things. So add is the most common one. Add will just add something to the end. Right? It's still a list, so the order matters. You can add something to the first position, the second position, the third, on and on and on, as you go, right? And the position matters. But then you can also, if you want to add to a particular index, here you can say, hey, I want you to go to this location. Now doing this with a regular array is a little bit obnoxious. So if I had this list of names here, right, and I wanted to add something, say, between Jasmine and Joy, I'd have to go move all of these ones down one position, assuming there was room, and then add something new at that index 2. Right? This is index 0. Index 1, this is index 2. I'd want a new item to become index 2, and everything else would have to slide down. Array lists do that work for you when you call add. So you can add just the string, or you can add a particular index. You can add the string. You can add all, you can add another collection. You can add another array list together. You can add it to a given index. You can clear it. Clone will make a copy of it for you. You can ask if it contains a given object, which is really cool. Say, hey, do you have this inside of your list? Excuse me, the for each is a little bit more complex. We're not going to worry about that one right now. Now get is how you'd get a given value out. You can get a given index, or you can set a given index. You can get and set if you want, which is pretty fun. But we could say, you know, let's do a loop here. So we'll say here's a string for, how about friend? We'll just say is something here, and we'll say while friend.equals ignore case. Right? Anytime we're comparing strings, probably ignoring case if we're going to deal with user input. I doubt anybody has a friend named stop. So we'll say while our friend's name is not equal to stop, right, with our not here, do a little loop. We can say enter name of your friend or stop. Right, and then we'll get their input. So if we're going to be dealing with input, we need to use our scanner. We'll call it keyboard, because that's fun. There's a new scanner given system in. And we can get their, add or import, yes please, java.util.scanner, and we'll get their name. So this will be our string for friend. I'm sorry, just friend is equal to keyboard.nextLine. Now the downside of having to check it here is we need to check it one more time, right? To say, hey, if the friend's name does not equal stop, then I can take my array list of names and we'll call add, and we'll add our friend. Right? Because if it entered stop, we want it to stop running, right? Essentially. That's all. So it's a little bit of a bummer, you have to check it twice, but that's okay. It works out pretty well. So, lots of options for doing loops and things like that. This one makes sense? So we can just keep on adding as many times as we want to this array list. Right? And then our loops, again, so we can say for index is 0, index is less than. Now with array lists here, they don't have a length property, which is a bummer. They really should. They have a size method. So it's .size with parentheses, says how big are you? Array list of names. Oh, no, sorry, index plus plus. Right, so regular arrays, we can say, hey, I want the length property when we're looping through. Array lists, we use the size method here. Okay. Right, and then we use the get method. Right, so we can say this is my array list of names.get the index. We'll get the value out at that index. Or you can use the enhanced for loop. String friend name, sure, we'll say friend name in array list of names. And we can print out the friend name. So the enhanced for list looks the exact same. This is why this one is awesome. Right? A little bit easier to use than going through doing the other way around. And then you don't have to worry about the size because it just knows how big it is. Right? It's just always going to give you the right size here. That makes sense? So arrays or array lists. I'm almost always going to prefer array lists just because they're resizable. Now the downside of array lists, and it's not even really a downside, it's just something you have to remember. So if I want an integer array, like for numbers here, I can do that. If I want an array list of integers, I can't say array list of int or numbers. Right? This one is invalid here. And it tells you unexpected type, required reference found int. What that means is the only types that you can put inside of an array list have to be uppercase letter classes, which is not actually a problem because, remember, Java gives us these wrapper classes. So we have a class called integer, which can store ints. We have a class called capital D double, which can store double. You have a class capital F float, which stores lowercase f float primitives. So primitive types to their wrapper class types or reference types, Java can take care of. You just need to remember array lists and only use classes, right? And classes will always have that capital letter. Our primitive types don't have primitives. Yep, so it doesn't recognize it. So if you click the little light bulb, it should say, hey, do you want to import java.util.arraylist? Is that Trisaurus? Am I pronouncing that right? I think I am. There's a little bit of some Java magic that happens here that you can only use classes. I mean, they're helpful. I think it's kind of a silly distinction that they could have taken care of, but they didn't bother, and that's okay. Certain things will only work because this is a given class. When we get to that whole chunk on classes, inheritance, and all that object-oriented stuff, this will probably make a little bit more sense. Let me talk a little bit more about why this is, but everything has to be a class for some of this magic to work. And that will make more sense probably next week or the week after. Sorry to kind of punt on that one, but that's pretty much what it is. Yeah, it's just the way that they designed Java. That's all. Other languages handle a little bit cleaner, but it kind of makes sense. But yeah. All right. So that's regular arrays and regular array lists. Now we're going to take a second and we're going to go a step deeper, and we're going to make two-dimensional arrays or array lists. And these ones are lots of fun. So let me actually open up like Word here. Works out pretty well actually for drawing stuff. So if you were to think of a regular array, right, it has a row and it has indexes, right? So index 0, 1, 2, 3, 4, 5. Nope, that's in the wrong location. 6 and 7. I think star is fine. There may or may not be something ever so slightly slower in the compiler if you use star, but no, it should be fine to use star. Generally, we prefer being very specific, just so you don't clobber other things. Like when you get to large enterprise applications, they're importing oodles of things. So generally being more specific makes sure that you only get the same thing with the right name out of the right package. Because it's possible to have two different things named ArrayList. So like if you import all of java.util and you import another location that has the same name, you can run into issues. So I mean, generally more specific is better, but for the stuff we're doing, star is perfectly fine. Yeah, you can import java.util.star and it'll import everything, but NetBeans always suggests the specific, so I just go with that because I just add them as they suggest, as they get suggested. All right, so this is our regular array here. Now, a two-dimensional array is an array of arrays. So what we really have here, and this doesn't fit very well, but you'd have an array here, and an array here, and an array here, and an array here, right? Visualizing it that way is a little bit tricky, but it works. Most of the time when we think of a two-dimensional array, we think of it as rows and columns. So I would imagine here's this array, here's this array, here's this array, here's this array. So this is row 0, row 1, row 2, row 3, which is, right, this is index 0, this is index 1, this is index 2, this is index 3. Right, so we just kind of flip it on its side here to imagine it more in two-dimensional space rather than one big long line. And then what you get is inside of here, then, you can have individual indexes as well. So you can have index 0, 1, and 2, and we would think of these as columns, right? So for any given row and column, right, we could find that row and that column here, this way. Right? So rows and columns tend to make a little bit more sense when we think about two-dimensional arrays. So for any given location here, then I would say, hey, at say row 2, column 1, let's put an X here, that sort of thing. Right? So we could build out a quick little two-dimensional array here. And we could do array lists, or we could do arrays. Either one is perfectly fine. Let's just do a basic array. How about let's do a char array. And with a two-dimensional array, it's a array. We'll call this the board equals a new char array. Let's go. Let's do the initializer syntax. Let's do that. Let's do a space, a space, and a space. Oh, but all this needs to be inside of an array here. So this is with the initializer syntax. We're going to do 3 of these. Let me give that a format. Nope. Tab that a little bit. All right, that's still a bit ugly. Should be okay. And a semicolon. There we go. So this here then, let me back that up. There we go. We'll just back it up too. Is a 3 by 3. 3 rows and 3 columns for my board here. Using that initializer syntax. Right? So to get out a given location, it's a board of what row and what column. So 1 is going to get me this center mark here. This is row 1, column 1. We can assign, how about an X? Right? If we're going to play tic-tac-toe, we can put an X there. Right? It would set that here. And what we want, right, if we want to print this thing out, oops, I have too many curly braces now. Now, I want to write a method here for printing, because I don't want to have to print this multiple times, and just saying printing that out is going to get me garbage. So I print out my board here. It's not going to look very pretty. Right, I can print out the board. It's going to tell me, hey, it's going to look funny. Yeah, array instance printed on a print stream, yeah. It's saying you did a funny thing. So we'll just say stop. We don't need to add any friends. We get, right? We get garbage. That's not what we wanted to have printed out on the screen. But this is the two-dimensional array of characters, right? Array of type character at some memory address. That's not very helpful. So what we can do is we can write a method for it here, where we'll call this, how about it, public static void print board, given a char array, we'll call the board. Right, we can pass it an argument, here being our board, and we'll call print board here every time. What's going on with my mouse? Goodness. Okay, there we go. The sensitivity got all screwy. Now what we want to do is I want to say for row, this is a character array. I'm going to call row in the board here, right? Because this is the every row, which makes up the dimension. So this gives me every row of the board, right? I'll get this row, and then I'll get this row, and then I'll get this row. Here we can now pretty much we can print out row kind of easily, because printing out a single array should work out okay. And the nice thing is when we print that out, we go stop, it just prints. Right? We get our 3 characters, we get our 3 characters. 3 by 3. So maybe it'd be nicer to put something in between them here. Sure, we could do that. Not too big of a deal, but that's essentially it. So let's make this a little bit prettier then, right? Oh, I just have to go back to this tab. So instead of printing out each individual row, then, let's say I want to, I'm trying to think of how to do this nicely. Let's, I don't know, it might not be the prettiest, so that's okay. So we'll print, I want the board at 0, 0, and then I want to print a pipe character, and then I want the board at 0, 1, I want a pipe character, and then I want the board at 0, 2. Right, so that should be the first row. And then I want to print a bunch of dashes. So 1, 2, 3, 4, 5 dashes, I think. And then I want to print this again. But now I want row 1, row 1, row 1. And then I want to print my dashes again. And I want to print row 2 here. Row 2 and row 2. Okay. Hopefully now it looks like a tic-tac-toe board. Let's give that a shot. So we'll stop. And here's our empty tic-tac-toe board. Here's our tic-tac-toe board with an X. That's a little bit better. Again, still not like the prettiest looking output, but that's probably okay. And then just for fun, let's do one more empty print line here just to get like another new line in between. So you can put an X down. Right? And then maybe we'll play, hey, where should O go? How about O goes at 0, 0? 0, 0, we'll put an O down. That sort of thing. Right? And we can start playing tic-tac-toe. We can print the board. That sort of thing. Does that make sense? Right, with this two-dimensional array list. So now I get, here's X, here's O and X, and then it'll be X's turn, and on and on and on. We can just keep on taking turns until either someone is won or the game is over. Right, with two-dimensional arrays. So that's the regular array. You can do the same thing with array lists if you want. It's just a little bit of a different syntax. There's no imports for printboard. We just made another method here. So outside of the main method, right, everything had been done in main. We just said, hey, I want to do another method here. We're going to call it printboard, given the two-dimensional character array. Yep, so we'll have a chance to practice this in lab. We'll do a different thing. Okay, so there's our two-dimensional array here. So if we want to do that with an array list, right? So we'd have an array list of type. Well, what type do we want? So like in this case, we have an array of arrays, right? So we have a single array, and what it contains is arrays of characters, right? This sort of idea. So here's my array of arrays. Same thing with the array list. So the type here then is array list of type, and then we can do character with the wrapper class. This is my board 2. Sure, we'll call it board 2 equals new array list of type character. There we go. Now the funny thing is, it just lets me do a single diamond here. They call this the diamond operator. You don't have to specify what's inside of it because it says, hey, you already told me what's inside of it. You can put it there if you want, and it will like give you one of those suggestions like, oh, hey, you don't have to do this. It says redundant type argument in new expression. Use diamond operator instead. So you're welcome to just do the single diamond here. Now, it's empty to start, so we have to go put some in. So I need to take my board 2, and I want to add a new array list of type character. This is row 0, right? And then I need to add it again. I need to add row 1, and I need to add row 2. Row 1 and row 2. Right, now I have 3 rows in here. Now for each of those rows, I need to go and add some columns. So where this one, like you specify, hey, this is how big it was, or I could have said it was equal 3, 3. And the initializer probably a little bit easier here, but we got options. So now we need to go add our columns. So we're going to say for array list of type character, we'll call a row in my board 2, sorry, colon, in board, oh my goodness, colon is the in board 2. I'm typing the words that I'm saying instead of typing the character, I mean. You can say row.add, and we want to add a character. So we just say, hey, let's add a character. And really we want 3 characters. We can say 1, 2, and 3. So it'll get this first row and add 3 characters. It'll get the second row, add 3 characters. It'll get that third row and add 3 characters. So print board is the same thing here, but what I want to be able to print here now is an array list of type array list of type character. We'll call the board. Now I can't say board at 0, 0. Now I need to say board.get 0 will get me the 0 with row. .get 0 will give me the 0 with column every time. So all of these need to get replaced. I can't use the index notation, I use the get notation. So that was 0, 1 and 0, 2, right? So let me take this whole row and I'll copy paste on top of here, and I'll copy paste on top of here. And this is row 1, this is row 2. Row 1, row 2. Row 1, row 2, right? So same idea, but we don't use the square brace index notation, we use the get notation to get the values out. And now I can print my board. So we've added that one here, now we can call print board given my board 2. And again, this one should be empty, right, because it's empty. Right? We haven't added anything. So we can do either way, with array lists or arrays. Now there is no initializer syntax, if I remember right. That's probably worth a Google here. I don't think there is. So Java ArrayList initializer. Like initializer. Geeks for Geeks. Okay, they're halfway decent actually with some of their answers. Let's see. Yeah, just a bunch of adds. So you add a bunch of things. Shorthand notation. No, I don't want to sign up. No, thank you. Oh, okay, so we can, inside of that, we can call add. I guess it's a little bit easier than calling .add every time. That's funny. Sure. We can do arrays as list to give it a list here. Sure. Not sure that's, I guess it's a little bit easier. list. Okay, so we've got a couple of options, but not really anything super easy, which is kind of a bummer here, right? Not as easy as when we do our regular arrays. Okay. That would make sense? Okay, so what we can do from here, right, if either one you want to use is perfectly fine, we're going to try and flesh out the rest of the tic-tac-toe game here. Right, so we're going to get some code going here, and we're going to turn it over to you folks to finish for lab. It's kind of the idea here, okay? Just get some practice with these two-dimensional lists. And you can use the array list, or you can use the array, whichever one you prefer. You don't have to do both. I figure if you can do one, you can probably do the other. It's not too bad. But just pick one. Right, so which one do you want me to start with? Do you want me to start with the array version or the array list version? I can do either. And we'll sort of get some starter code, and we can go from there. I'm open to either. You just let me know. Array. Okay, so we use the array version. So again, we don't really actually want to start these moves here like that. So I'm going to take those ones out. You know what? Let me leave them commented. How about that? Let's just go to source and toggle comment. Control /. That's right. We'll comment those ones here. So we'll say current player equals X here. Oh, sorry, that should be a character. Right. Now I'm going to flush out some methods here, but not actually write all the methods. So we're going to say while not game over, given the board. Right, and we don't have a method named game over, so we need to come up with a method, right, public static, that returns a boolean for game over, given the character array of board. And again, if you're doing array list, just swap the type here. No big deal. Right, so for right now, I'm going to return false. Right, this is, you need to actually write this here. To do. Right, you'll go finish this. But really, there's two ways that a game is over. Right, the two ways that a game is over. Let's call this one. We can actually do this one. We're going to return tie game, right? Or player won. Player wins. Give it a board, right? Each time, given the board. So if either the game is tied or someone has won, yes, the game is over. That's true, right? And we can OR those together. Either one of those is true. Great. Right, so then we need some more methods here. We need a tie game and we need a player wins. Right, there's a tie game. There's a player wins. Give it that a little format here. So for a tie game here, check if all the spaces are full, right, or none are empty. So for now, I'm just going to say return false. And you can go figure this out later, right? So this is the to-do. So we either have to check to see they're all full or none are empty, right? If there's an empty space, there's not a tie game. If someone won, now this one gets a little bit trickier here. This one's another to-do. Again, I'm going to return false for a second here, but I want to break this down to be a little bit easier, right? This idea of functional decomposition. So if you hadn't had me before, hopefully you're learning a new term here. It is my favorite programming term of all time, functional decomposition. We're taking a big problem and we're breaking it down into smaller and smaller and smaller chunks because smaller things are easier to solve. So there's a couple ways you can win, right? So we can return player wins vertically, given the board, or player wins horizontally, given the board, right? Or player wins diagonally, given the board. So we don't even need this return false. This one's done. Now, the tricky part is you have to write those three methods now. And it's going to say those methods don't exist, so let's use our little shortcut here. Let's create a method. Here, which one do we want? Given, yeah, both of them. Both are good. Both are good. All right, we'll just let it create the method for us. So that way you don't even have to copy paste. Right? And we should get 3 new methods here. I think it puts them down at the bottom. Here we go. Okay, they make them private. That's fine. Private or public doesn't really matter at this point here. That's perfectly fine. But we don't want to throw an unsupported operation. Not implemented yet. That one's no good. Oh my goodness. Get rid of that line. There we go. Here. And again, get rid of that line. Get rid of that line. Okay, so to check if we win vertically, we need to check each column. See if all three are not empty and match. Right? I'm going to just say return false. So for each column, if all three of them are the same character, either an X or an O, we don't care which one. As long as they're not empty and they're all the same, someone won. If we've checked all three and we haven't found a winner, we can return false. Same with horizontally. We're going to check each row, see if all three are not empty and match. Right? Return false. If it's not empty and they match, we have a winner. If we've checked all three, we don't have a winner, we return false. Now diagonals are a little bit trickier. So you can do one of two things. My favorite way, right, is we're going to do this again. We're going to go nuts here. So we'll say player wins diagonally up, given a board, or player wins diagonally down, given the board. And we can return those, right? Because diagonally could be either direction, right? So I'm going to pick here's diagonally up and here's a diagonally down. So you know what? Let's just copy paste. Diagonally up and diagonally down. Oops, I need this whole thing. Diagonally down. Oops. Diagonally down. Return false. Return false. Now these ones, I'm sure we could come up with some cute ways to figure this out. But really it's just, hey, check this one and this one and this one, or check this one and this one and this one. Right? It's just check those three different indexes to do, right, check three indexes, or check three locations. If they match and if they are not empty, match, someone won. Right? So either someone won yes, or we return false, no one won. Okay, same idea with this. Okay, so that's excuse me, that's game over. Right? That's about it. Okay, so we got a couple things to fill out here, but while the game is not over, we can print out, I don't know, current player's turn. Current player plus turn. Pick a row and column to place your piece. And then we'll go get their input. Now, dealing with input is a little bit tricky, but not the hardest thing in the world, right? So we have an int for row is going to be integer.parseInt given the keyboard.nextLine. Right? Row, pick a row, and then pick a column. Pick a column to place your piece. Sure. I mean, we can do it one at a time like that. We have all sorts of ways. You know, this is fine if you want to change it up. No big deal here. But here's row and column. Okay. Now we need to make sure that that location is valid and empty. So my to-do is check if row and column are valid, right? Which means they're between 0 and 2, and the location is not empty. Right? That sort of thing. We just keep on going. Right? If it is valid, or right, if it's not valid, we want to keep going here. Right? Essentially repeat this again here. So we could do another loop here. Right? So while I don't know, how about we'd have we'll define int row and column up here, I guess. So int row 0, column is 0. You know, actually, I'm going to start them off at -1 because those are invalid here. We'll say while invalid row or column, given the row and column, we're going to keep on going, right? And then we don't need to reassign row or don't need to redeclare. Right, so we need a method here. Let's create a method. Sure. Get rid of that starter code. Oh, so if we're going to do that, we also need the board. Bummer. Character array of the board to make sure that's a valid spot, right? We also need to pass it the board. Because that way we can check to see if it's empty, right? We've got the board. Char. Oh, did I type it wrong? I typed it wrong. Oh yeah, that's too many square braces there. There we go. So if you give the board and the row and the column, we can make sure it's in a valid location and it's not empty. Right? So this is true, it's invalid, or false, it's valid. Right? So like true means it's invalid and we have to keep on going. Right? Otherwise, we're going to take our board at the row, at the column, and we're going to set it to the current player. Right? And then we need to flip it. So if my current player is equal to X, then my current player will equal O. Right? Double equals, there we go. Otherwise, current player goes back to X. Right? If it is X, it goes to O. If it's not X, it goes back to X. If we play to move. Then we check while the game's not over. Right? That's it. That's all we have to do. What's upset here? Variable row is already defined. Oh, I have a row there. Okay, so we just need to change this one here. So we'll call this, I don't know, how about current row? Sure, we'll change that. Okay? That sound okay? So what we're going to do then, oh, and this needs to be just for now so that it stops yelling at us, I'm going to return false. You can figure that out after the fact. We'll move this up a little bit here. How about we do this one up here? Sure. Okay, so we got a bunch of methods we need to finish filling out here, right? All these to-dos. To-do, this one's a to-do. So we can play tic-tac-toe. Okay? Is that a format? Why did that format it funny? That's okay. I want those in a little bit. There we go. If you grab more than one row, you can tab, and then you should tab in. Are you guys with me so far, or have I gone off the deep end? You doing okay? This is our tic-tac-toe game, right? While the game's not over, pick a row and column, make sure it's valid, right? If it's invalid true, we keep on looping. A stretch, thank you so much. All right, well, we've got the rest of today to work on this lab. So this is the point at which I'd like to turn it over to you folks. So let me commit this to GitHub here. This is arrays and array lists. I'll commit and push. Coffee is kicking it, so I know I gotta go get my coffee. So let me publish this here. I'm gonna go repository, view on GitHub. Open up that link for me. And then, so for lab 1, we're gonna go and finish tic-tac-toe. That's what we're gonna do. Get it up here. So I'm gonna learn, let's go. And then I'm going to just go grab this code here, and I'll link it right for you. So starting in, I don't know, just here, sure. Why not? So just practice working through these arrays and array lists to check those things, right? We're going to finish how we can tell whether or not the game is over, whether or not someone won, or it's a tie game. Right, so we've got some of those out there. So let me start up a new lab. This will be due in a week. And ideally, we're done before you walk out the door, but that's okay. Not too much pressure. We'll call this lab 1. Lab 1, arrays, array lists. So due in a week puts us at the 25th, right before class starts, 10 a.m. We'll make a new lab here. So we're going to complete the tic-tac-toe logic. That copy paste never works for me. I don't know. Something about, I don't know, copying out of the URL box just fails. I don't know if it's like picking up another line or what. Okay, and you need a text submission. So you can just copy paste this, copy paste to your project repository. So let me get you a new repo for that. I think it's easiest to start a new project in your repository. I'm going to make you a link here in a second, and then you can just copy paste in this stuff here, and then trim out the stuff you don't want. Probably easiest. All right, so let's do 2151. Does it not copy paste well with NetBeans? It should. I haven't had a lot of trouble with it before myself. It's 2151, enter 2022, lab 1. Oh, okay. Is it the website itself is weird, or is it... Yeah, Alt-Shift-F for format is definitely your friend. Or go to just the source menu and hit format. That's definitely a good shortcut there. Lab 1, why can't I continue? It is thinking about it. There we go, continue. Yep, so the feedback pull request, once you've committed your code here, let's see, I don't have it handy here, but I've got a lab 0, or Chernesky. Oh, come on. Chernesky. I can spell my name, right? Didn't I do a lab 0? Pretty sure I did a lab 0. Maybe I typoed it. Of course, it doesn't want to cooperate with me right now. That's okay. Let me pick my from here. I did a lab 0. Oh, it's in the wrong. That's why. This is in the OCC repository. So view on GitHub. There we go. So once you're viewing your repository here, right, make sure your code made it. You get your folder for whatever that you created your project. You go to the pull requests link here, and you click on feedback. Again, you can sanity check, go to files changed, and you should see, usually it's the last one at the bottom, is your .java file with all your Java code. So just give me this URL, you're going to copy paste that into D2L, and we're good to go. All right, there we go. Now it's loading. Java template. I don't know why it's being so super slow. That's crazy. Close with this other stuff, I guess. Maybe it's just my computer. Probably is. Let me close NetBeans. There we go. That'll save us some time, right? If I can close NetBeans down. Maybe. Maybe. It's just the internet. Yeah, I'm getting that. Submit the URL to the feedback pull request. And I'll get you that link in a second. Almost there. Oh, I've seen that where like the clipboard gets stuck, right? Like I know what you're talking about. Yeah, I've seen that happen, and then you have to like close NetBeans and reopen it. That is nuts. Yeah, I don't know what triggers that. I haven't had it happen to me in a while, so I thought it might have gone away with one of their latest versions, but sorry to hear. Come on, friends. Java template. My goodness. I don't know why it's being so particular. I'm sorry. It's almost there. They programmed me to work within its parameters. Yeah. Yeah, I guess I just got used to it. There we go. Here's our Java template. I do have Comcast, yeah. It's been decent for a while. I think the stream's actually been pretty decent too. Like for a while, last year I had trouble. I had to get the tech out here to take a look at my line. Apparently I had a bad loop. It was collecting water in the connection from the house to the pole or something. So you replaced that for me. But maybe it's just GitHub. I think like D2L seemed like it was okay. Maybe it's just the GitHub tool. That's right, yeah. Sorry about that. Oh man, losing games from lag sucks. That's a bad feeling. Definitely, you get a feels bad man here. Come on, there we go. So this is one of my favorite emotes from Gotham Chess. Sad Batman. All right, it's almost there. It's almost there. Come on. All I need is the URL now. Oh, you got kicked for the lag? Ouch. That's no fun. I know, I have to hit save, but I want the GitHub link, so it'll be there in just a second. Trisaurus. It's almost ready. I want to give you the link to create a repository, and it's not doing it. It's so close. All right, well, why don't you folks get up and stretch, and then we'll get working on this. I'll post this. Oh no! Respond. Refresh. Maybe it'll work. There it goes. No tests. Feedback pull requests. Create the assignment. Oh, it was so fast. It was there. Yes. Okay, got the link. All right, and there is lab 1. Come on, D2L. All right, there we go. So now we got lab 1, arrays and array lists, ready for you. Got a week to get it done. Again, ideally you get it done before you're out of here, but if you need to take a little more time, that's no problem. Let me know what I can do to help, and we'll go from there. On Thursday, we'll pick it up with files, and then we'll look at our first project as well, okay? All right, folks, we'll call it a day on the streaming. I'll export this out to YouTube, and we can go from there. You folks have a good one.